In this video, we're looking at National 5 Chemistry calculation questions. Specifically, we're going to look at everyone's favourite, which is the titration question. So a good place to start is this word example. We do 3 titrations to determine the concentration of a sample of 25 centimetres cubed, so we know the volume of hydrochloric acid, but we don't know its concentration. And we're using 2 mole per litre sodium hydroxide. When we do this, the titer values, so the volume of sodium hydroxide needed to fully neutralise this sample of 25 centimetres cubed of hydrochloric acid, range from 20 to 19.6 to 19.9. So we're going to try and calculate the concentration of the hydrochloric acid. Now, the titer volumes have to be concordant, so if we look at these numbers, they should be within 0.2 of each other, just like 18.7 and 18.9 are within 0.2 of each other. So 20 and 19.6 are 0.4 apart, so they're not concordant, and 19.6 and 19.9 also not concordant. However, first and last ones, so 20 and 19.9 are concordant. So we take those, we'll take the average of those, so we add them together and divide by 2, we'll get 19.95 centimetres cubed. That is the average volume of sodium hydroxide, if we ignore the non-concordant ones, that it took to neutralise this hydrochloric acid. It's pretty decent, 19.95. Now, the equation we're going to use here is the concentration times volume over the number of moles in the balanced equation equals the concentration times volume over the balanced number of moles in the equation. So it doesn't really matter which way around you put it, but I tend to go with whatever's in the burette being on the left-hand side and whatever I'm trying to find out on the right-hand side. So if we look through this, the sodium hydroxide, its concentration is 2, because it tells us that in the question. So the concentration is 2 moles per litre sodium hydroxide. And we've just worked out here that the average titer volume is 19.95. So when you multiply those two together, you're going to get 39.9. The hydrochloric acid, it tells you here you've got 25 centimetres cubed of it, so that's your volume. But the entire point of the question is we don't know its concentration yet. Now, N comes into vogue here. So we look at the balanced equation. So if you take 1 mole of hydrochloric acid and 1 mole of sodium hydroxide, you'll get a mole of sodium chloride, salt, and you'll get water. So because there is no balancing number, if there had been a 2 here, that would have been a balancing number, and that would have meant we would have had to put 2 underneath here, so divide by 2 here. But there isn't one. It's a 1, a 1, a 1, and a 1, all the way through the street. So we can just ignore this N thing. So CV will equal CV. So the concentration times the volume of sodium hydroxide will be 19.95 times 2, which we've already said is 39.90. That will equal 25 times the concentration, which is 25C. Now, if 19.9 is 25 times higher than what we need, because it's 25C and we just want C, we're going to have to divide it by 25. So 39.9 divided by 25 will give us 1.6 moles per litre. And it's really important that we put in the units here in moles per litre. Okay, what you can also do at this point is you can say that we roughly 20 mils here of sodium hydroxide, and it's 2 moles per litre. You've used more hydrochloric acid than that, so you would expect the concentration to be lower. So you can just use a kind of scent check to make sure the numbers seem reasonable. Let's go through some practice examples. So the average concordant result in the following titration. So let's have a look. This one is just not asking us about CV over N, it's just asking us, do we know what concordant results are and can we spot them? So we're looking for, so starts at 0 goes to 11, so 11 starts at 11 goes to 21. So we're looking for which one of these are concordant. So 11 and 10.1, nowhere near concordant. 10.1 and 10.6, nowhere near concordant. 10.6 and 10.3 not concordant. The only ones that are within 0.2 of each other are our titration 2, so it's 10.1, and our titration 4, which is 10.3. So I would take those two, and I would take an average of them, and an average of 10.1 and 10.3 gives us 10.2. In question 2, also from the 2025 paper, so they checked we know what concordant meant, and then we see if we knew how to use the numbers. So the average volume of sodium carbonate used in an experiment was 21 centimeters cubed. Sodium carbonate reacts with hydrochloric acid in the ratio shown. So this is where N is going to come in here. So it looks like the N number for our sodium carbonate is 1. So it's going to divide by 1. So again, because it's dividing by 1, we can ignore it. But for the hydrochloric acid, we will have to acknowledge that it's being divided by 2. So the concentration times volume of the sodium carbonate with concentration is 0.1, and the volume, it tells us, is 21. So 0.1 times 21, we'll just write it here while we're going through, will be 2.1. So 2.1 equals the concentration times volume of hydrochloric acid divided by its number of moles. So we don't know the C, so we're going to have to work that out. But we do know the V. So the volume is 25. You should most likely convert these into litres because it is moles per litre, but because it's a ratio between the two sides, it doesn't really matter. So it's 25 multiplied by C divided by 2. So if we times both sides by 2, we can get rid of the over 2 bit. So it becomes 4.2 equals 25 times C. And then we do what we did up here. We divide both sides by 25 and you get 0.17 moles per litre. Question 3. The average volume of oxalic acid should be used to calculate sodium hydroxide concentration is 10.6. This is the table of data here. So we've got the volume used here is sometimes difficult because it's in a different orientation than up here. So in the first, second, third titers, we've got 16.4, 15.5, and 15.7. And after a while, we get quite good at going, the 15.5 and 15.7 are concordant. So they're the ones we're going to be using. Explain why only the results of the second and third titer are being used. It's because they must be concordant, they must be within 0.2. So we see where this 15.6 has come from. It's the average of the two concordant ones here. Using the average volume of oxalic acid of 15.6, so they like that number, in 2024, calculate the concentration of sodium hydroxide solution. So here we know that they used an average titer volume of 15.6. So it would be 15.6 multiplied by the concentration, which is 0.1, which gives us 1.56. We don't have a balanced equation, I was about to say, but we do down here. So it'll be 1.56, which is the volume times the concentration, divided by, well, oxalic acid doesn't have a balancing number in front of it, so it's just 1.56. So it'll be 1.56 equals the volume on the other side, so 10, multiplied by the concentration, so we've got 10C, but there is a balancing number of 2 here, so it will be divided by 2. So 1.56 times 2 is about, I don't know, 3.2. So 3.2 equals 10 times C, so C will equal 0.32. I'm going to assume that the calculator maths I did previously is better than the mental maths I've just done, but either way, that is the method for how you do it. A titration was carried out to neutralize 0.002 moles of sulfuric acid solution. Calculate the number of moles of sodium hydroxide solution required. So this one, you actually don't need to do the full shebang of CV over N, CV over N. They're just saying if you use 0.002 moles of sulfuric acid, which is this one here, how many moles of sodium hydroxide will you need? Well, you'll need twice as much because it says here that for every 1 mole of sulfuric acid you use 2 moles of the sodium hydroxide. So if you use 0.002 moles of sulfuric acid, we need 0.004 moles of the sodium hydroxide. Number 6, the titration is carried out using sodium carbonate and hydrochloric acid. The equation for the reaction is below, and apparently so is the answer. So we should be getting good at this. Calculate concentration of the hydrochloric acid. So it will be CV over N equals CV over N. It looks like the concentration of sodium carbonate is 1. So 1 times the volume, which is apparently 10. So 10 divided by whatever the balancing number is in front of sodium carbonate, which is 1. So they've really given us an easy one here. 10 equals, oh, there's a 2 there, that'll be divided by 2. So 10 equals 20 times C divided by 2. Now, we've been multiplying both sides by 2, but you can actually just do the sum. They've told us 20 times c over 2 equals something. So 20c over 2 is the same as 10c. So we've got 10 equals 10c. And that's actually a lot easier to do. So that means that each c will be 1. So c is 1 moles per litre. So you can multiply both sides by 2, or if it's easy enough, if it's not too tricky, you can just do the sum on the sides. We had 20 times c over 2 because of this 2 in the balancing number, and that is just 10c. A student investigated the concentration of chloride ions in drinking water. If the average titer volume is 9, so we've got the volume of sodium nitrate, we just need its concentration. So it says calculate concentration of chloride ions in the water sample. So let's have a look. We know the volume is 9, we know the concentration is 0.02. So 9 times 0.02 is 0.18, divided by whatever the balancing number is, it's 1, so it's just 0.18. 0.18 equals, so on the other side, concentration times volume over n. Concentration is unknown, that's the point of the question. Volume is 20. And in this case, the n is just 1. So we had 0.18 equals 20n. So divide both sides by 20, you'll have 0.009 moles per litre. And the final one we're doing, I think there are more, but we'll just end on this one. Calculate the concentration in moles per litre of vitamin C in the orange juice. So we've got a balanced equation, it's 1 to 1, which means we're going to just be able to ignore the ends. And then we come down here. And now what we want is we want a volume for the iodine solution. So we look at this, titrations 1, 2, 3, which ones are concordant? It looks like these two, 15.9 and 16.1, they are concordant. The average of those two will be 16 on the buzzer. So 16 times 0.005 is something like 0.08-ish. That 0.08 equals 25 times C. So divide both sides by 25 and you get 0.0032. Nice and easy. So hopefully that makes sense. If you need to ask any more questions, please do make contact with your teacher.